Well, hello class. If you forgot me, this is Mr. Z, and I need to add some notes to Module 20.2. We've been using your Flipbook so far in this unit, but there are some new things being introduced in this unit that are not in your Flipbook. In fact, there's a couple of videos that I'm not assigning you from your Flipbook, but you can find those in that same playlist that you've been watching already. So there could be some room you could squeeze in here, but I would just say add these notes to your notebook. So here we go, 20.2, arc length and radian measure, and the essential question is, how do you find the length of an arc? I'm not going to wait for you to write that because you can just pause the video. So I'm assuming you've gotten your essential question written down. Let's go ahead and continue. Now class, as far as arc length, you've already taken notes on that. In the Section 4 top flap of your Flipbook, you see we talk about circumference, talk about how to find the length of an arc, and this is different from finding the measure of an arc. The measure of an arc is in degrees. The length of an arc is in units. It's the distance from point D to point F, or the distance from here, in this case from here to here. So we convert degrees to units of measure, and that is the length of an arc. So that you already know. We're going to introduce this other part which is not in your Flipbook, and that is this idea of radians. And the first thing I'm going to show you on this slide is, you're familiar with degrees. We can take a circle. If we start at 0 degrees and we move counterclockwise, here's 90, a semicircle is 180, 3/4 of a circle is 270, and then we get to the full circle, which is 360. Radians are measured a different way. Radians are based off of something you'll see next year called the unit circle. If we have a circle that has a radius of 1 unit, then class, the circumference is then 2 pi r, which is 2 pi times 1, which is just 2 pi. So the circumference of a unit circle is 2 pi. We'll start with 0 just like we would with degrees, but now when we get to the top, it's not 90 degrees, it's pi divided by 2. A semicircle is pi radians. 3/4 of a circle is 3 pi over 2 radians, and then when we get to the full circle, we've got the full circumference, which is 2 pi. So here is the relationship between the degrees of a circle and the radians of a circle. So how does this play out? In this unit, you're going to need to know how to convert from degrees, and I'll represent that with m for measure of the arc, to radians, and I'll just use RAD because that's usually the way calculators will abbreviate radians. So here's our two circles. It's actually pretty easy to do. If you look at this, we can actually create a proportion. 180 is related to pi as any other measure in degrees is related to radians. So basically we say, if we know that this fraction is true, then we know we can take any measure, and that's going to be divided by radians. This proportion will always be true. So now all we want to do is, if we want to convert degrees to radians, we want to get radians by itself, and that's going to give us the formula for converting degrees to radians. So the next thing is, I'm going to cross multiply 180 times radians, so I put that here, and then pi times m, or measure times pi, is here. Now we're going to go ahead and we want to get radians by itself. We'll divide both sides by 180. And now you can see, class, radians is just the measure in degrees times pi over 180. So it's pretty easy to get from degrees to radians. How about from radians to degrees? Well, we'll start off with the exact same proportion. We know that 180 is to pi as any degrees is to its related radians. So now we're going to cross multiply again, only this time I'm trying to get the m, or the degrees, by itself, so I can figure out how to get degrees from a known radians. So now I've got pi times m, or m times pi, equals radians times 180. I've just cross multiplied. And now I'm going to divide both sides by pi. And now I know the measure of an arc in degrees is equal to the radians of that arc times 180 divided by pi. So these are the two formulas you need to know. And if you forget them or don't memorize them, as long as you can set up this proportion, you can either solve for m or, like the previous screen, solve for radians. So now let's see how this plays out. So I'm going to go ahead and convert 30 degrees to radians. If you want to pause the video right now and do this yourself, you can do that as well. Hang on one second here, class. Let me make sure my video is working. All right, we're good. So you can do that as well. Let's go ahead and pause the video if you want to, and then start it back up again. Let's see how we do this. All right, if you are back, here we go. I'm going to find the radians, and that's going to be equal to the measure of the arc, which is 30 times pi over 180. And now I'm going to simplify this. Radians equals, so I can simplify this as 30 over 180. 30 goes into 186 times, so that becomes 1, and this becomes 6. And I've got radians equals pi over 6. So that means 30 degrees on this circle is equal to pi divided by 6 on this circle. So that's how you convert degrees to radians. Next part is, how do you convert radians to degrees? It's just as easy. Here's my formula to go from radians to degrees. So I'm going to say my measure of my arc, or my degrees of my arc, we're going to start with 2 pi over 3. So I want to know, what is the degrees of the radian measure 2 pi over 3? We're going to multiply that times 180 over pi. This one kind of works out pretty nice. We can actually cancel pi. We can simplify this. 180 divided by 3 is 60. And that changes this to 1. And we've got 2 times 60, which is 120. Oh, actually there's nothing in the denominator, so I can just write right here. Our final answer is 120 degrees. And if you visualize this, 2/3 pi is going to be somewhere around right here. We've got, here's pi, so 1/3 pi is somewhere here, 2/3 pi is somewhere here. Well, that makes sense that that same point on my degrees circle is going to be 120 degrees. So that's how we convert from radians to degrees. And the last thing you have to know before you do your assignment is, how do we deal with this thing called concentric circles? Now, a concentric circle is more than one circle that have the exact same center point. So if you see here on this diagram, I've got a small circle with the center right here, and I've got a larger circle with the exact same center. And the question you're going to get is, how do I find the length of this arc of my small circle if I know the length of this arc from my big circle? Well, you're going to have to know one more thing. You're going to have to know the radius of each of these. So in this case, you're going to say, okay, the radius of the big circle is 50 millimeters. The small circle is 30 millimeters. What is the length of arc X? Let me see if I worked this out already. Yes, I did. Class, here is where proportions come to the rescue again. I know that 30 to 50 is proportional to X over 72. 30 came from my small circle, 50 came from my big circle, and on this ratio, X came from my small circle, and 72 came from my big circle. So you can set every one of these concentric circles type problems up as a proportion, and then we're going to go through the same process we did before. Let's cross multiply. 50 times X equals 30 times 72. So 50x equals 2160. Divide both sides by 50, and you've got X equals 43.2 millimeters. So if we had concentric circles, and I knew the radius of each of those, and I knew that this arc was 72, I can use proportions to find the measure of this arc. That is the end of your notes. You have everything you need to be successful, hopefully, on this assignment. I believe it is YY. All right, class, have a good day and hopefully talk to you soon.